Hello Year 11 RDHS Chemistry class. So today I'm going to be taking you through the introduction to our first topic, materials and their atoms. So this subtopic is called the properties and uses of materials. I've structured this in this way that we're going to start off by first considering some materials, 1, consider then the uses that they have, 2, and then consider the properties that they have, 3. The reason we're going to think of it in this direction is because we want to first observe what is it that we see in society and in our everyday lives, what materials do we see, and then we're going to brainstorm what uses do they have, and then we're going to think what properties do they have. We can also do this in reverse, but to start off with, let's do it in this direction first. So, first we're going to consider what materials we use in everyday life. So, we use glass, we use plastics, metals, we use natural fibers, for example, wool. There's many different materials, but let's just start off with these ones for now. So, glass, we use these in bottles and so on. We use these in containers of sorts, so often in packaging of foods. Plastics, we use these in many different things. Let's just say we use them in packaging as well. That's a big one. Another one is in some structural and material cases where we're building different things. There's many uses for metals as well. We use them for many things, from structural uses for buildings and scaffolding and just about anything. And we also use them for batteries and technology. And these are obviously different types of metals. There's many different types of metals with different properties. The natural fibers, well, we use them for, say, a wool jumper. Now let's have a think of some properties. So what are the properties of glass that make it a good bottle or container? Well, glass is very hard, so that's one property. So that's a real positive, isn't it? So it's hard, so, it's not going to, bend if you want to have something very, contained. But then one negative is it's actually a bit brittle, so it can also break. So it needs to be the right sort of conditions for glass to be a useful material. Now, if we think about plastics, well, plastics can be hard as well. They can also be soft, and that's also a positive. So they can be used in different ways. And as far as the negative goes, well, they're not brittle. So this is another positive. So, for example, it's a lot harder to break a plastic item than a glass item because it can bend. So it can bend. We call this malleability. Now, metals have many properties as well. It's very hard. It has a very high melting point, which means it can get very hot, so it's very strong. And metals are also quite malleable. They can bend a bit, so they're less likely to break than glass. This is why we wouldn't use glass for a building structure, because obviously it would break. So when we think then of a wool jumper, why is a wool jumper good? Well, it's warm, so that's a property. It's also a good insulator, that's another property. So it's an insulator because your wool fibers have these kinks in them, and because there's all this space here, it forms a barrier between air, so it can't get across very easily. Now, we could unpack these even further and look at what's happening with the atoms, which we'll do later, that makes these properties the way they are. Now I'm going to quickly go over the properties that you need to know for this unit. So the properties you need to understand are solubility, thermal properties, electrical properties, melting point and boiling point. So we can now do this in reverse. We can go, okay, where do we use solubility? So for example, sugar, let's just say, it dissolves in coffee. So to sweeten things up, so we could go back here and we go, if we want to sweeten up a drink, we don't want to have sugar just sitting at the bottom like a cake of sugar and not being dissolved in the material. So we might use sugar because we know that it dissolves in water. But not every material dissolves in water. For example, fat does not dissolve in water. We think about thermal properties. We use these for cooking. So when we are going to be considering cooking something, we want it to be strong, we want it to be safe, we want it to not break. So we're not going to use a glass material. We're going to use something that heats up quickly and retains heat. And lots of metal objects are going to do this. So different metal saucepans. Say we also don't want it to rust, so we might use stainless steel. We think about electrical properties. So for transmitting, electrons through a wire, they go in this direction from, say, a battery to a light bulb. So what we need is a material that can carry these electrons. So there's lots of different materials that can do this, but the one we use is copper, because copper wiring has lots of what they call delocalized electrons that allow the flow of electricity to pass through the wire very easily. So we use copper wiring. Melting points. So let's say we're using some material, let's say our car bonnet or our engine. We want the engine to have a very low melting point. So let's think of where's something where we want a very low melting point. So we go the engine of our car. So we'll be using a metal or a combination that has a very, very high melting point. And this would be a form of steel, something that is going to have a high melting point. Obviously, not plastic. Boiling point, so same sort of thing. If we want to, have a low or a high boiling point, we can change that with different sorts of properties. I just want to draw your attention quickly to the idea of nanoparticles. These are very small particles that are used in different things. You maybe have heard of silica beads. They're very bad for the environment, used in shampoos or not shampoos, but face scrubs. So these have these little beads that exfoliate our skin, but they're bad for the environment. And then you have things like titanium dioxide, and this is a material that's often used as an antibacterial agent in some, packaging materials. And another fun one is you also have gold nanoparticles, which are currently being researched to how they can be used in chemotherapy and as an anti-cancer sort of drug. Technically also the COVID vaccines, the new ones, the mRNA ones, there's also lipid nanoparticles, which is how they deliver the mRNA vaccine. So you sort of have these lipids, which they are called nanoparticles because they're very small, and then you have the mRNA in the middle, which is basically genetic material, that tells our cells what to do. But that's another story. So anyway, here is an overview of what we've done today. We've looked at the materials and their atoms. We've looked at materials, uses, and their properties. We've broken that down. We've gone over a few different materials: glasses, plastics, metals, natural fibers, and then we've gone the reverse way around and had a brief overview of solubility, thermal properties, electrical properties, melting point, and boiling point. There is a lot more information about this in the textbook. Please go and borrow this when you have a chance. It's called the SASTA Stage 1 Chemistry Textbook. SASTA, let's write this down for you, Stage 1 Chemistry Textbook. It's at the library, and there's a copy for each of you to use, not as a workbook, but as a textbook, and then you can write your own notes on the side. Cool, I hope this was okay for you all. Thank you for your patience with online learning, and if you have any questions, please message me. Thank you, guys.